All right, let's take a trip. We're leaving behind everything we know about weather, about comfort, about life, and we're heading out on a tour. A tour of the most violent, extreme, and just plain hostile worlds we've ever found out there in the cosmos. Let's get into it.
No, seriously, think about it for a second. Are you picturing a Category 5 hurricane? Maybe a brutal blizzard? Or the hottest, most scorching day in the middle of the desert? Whatever it is, I promise you, it's basically a pleasant afternoon compared to what the rest of the universe is capable of.
Yeah, you heard that right. What we're about to explore are planets so out there, they completely redefine what a planet can even be. These aren't just rocks in space, they're nature's own cosmic laboratories, pushing the laws of physics to their absolute breaking point. So, here's our game plan. First, we'll visit the hottest places you can possibly imagine. Then, we'll check out worlds of insane storms and bone-chilling cold. After that, we'll see how planets can be destroyed by other forces entirely. And finally, we'll ask the big question, why do we even study these nightmares? What do they teach us?
Our first stop, we're diving straight into the fire. We're talking about a class of planets so unbelievably hot, they actually make our own sun seem, well, kind of lukewarm. These are the ultra-hot Jupiters, worlds locked in a fiery death hug with their stars. So, meet our first champion of hostility, Kelt 9b. And let me tell you, its nickname, the Furnace, is probably the biggest understatement in the galaxy.
Okay, just look at these numbers. The absolute hottest it's ever gotten on Earth is about 57 degrees Celsius. Feels pretty bad, right? Well, the day side of Kelt 9b tops out at over 4,200 degrees Celsius. That's not just hot for a planet, that is literally hotter than the surface of many stars. You know, at these temperatures, chemistry as we know it just gives up. Molecules, things like water or CO2, they just can't hold together. They get ripped apart into their basic atoms. The planet is so hot that its own atmosphere is puffing up and just boiling away into space, like steam coming off a pot. But all that heat can lead to some even weirder stuff. So say hello to WASP-76b, a world that's famous not just for being hot, but for having weather that sounds like it's straight out of a nightmare. Just let that sink in for a minute. The side of the planet facing its star is so hot that rocks and metals, including iron, vaporize into a gas. Then super strong winds whip that iron gas over to the slightly cooler night side. And what happens when hot gas cools? It condenses and falls as rain. Molten iron rain. This isn't science fiction, it's the actual weather forecast on WASP-76b. But hey, it's not all about scorching temperatures. Some planets have figured out other, equally creative ways to be absolutely terrifying. So let's move on from the furnaces to worlds that are defined by their unbelievable storms and unimaginable cold. At first glance, this planet, HD 189733b, is famous for its gorgeous deep blue color, kind of like Earth from a distance. But trust me, that's where the comparison ends. This beautiful blue dot is a world of non-stop, brutal violence. Think about the most powerful hurricanes on Earth. Their winds top out around 300 kilometers per hour, which is terrifying enough. So, what do you think we're dealing with on a planet like this? 9,000 kilometers per hour. That's not a typo. That is 7 times the speed of sound. We're talking about winds so fast, they literally break the sound barrier. But, it gets worse. So, you know that beautiful blue color? That's not from oceans. It's from tiny particles of silicate, basically glass, in the atmosphere. And those supersonic winds are whipping those glass particles around the planet in a permanent global storm. It's literally raining glass, sideways at thousands of kilometers an hour. And this is what's so amazing. It just shows you the sheer range of awful out there in the universe. We've seen Kelt 9b, a furnace so hot it destroys molecules. And then, on the complete other end of the thermometer, you have this planet, OGEL 2005-BLG390LB. It's so far from its star that its surface is just a frozen, dead wasteland at minus 220 degrees Celsius, a deep, dark, permanent ice age. So far, we've seen extreme heat, extreme cold, and extreme weather. But the universe has some other, more insidious tricks up its sleeve for making a world uninhabitable. Let's look at planets being torn apart by radiation, crushed by pressure, and even tortured by gravity itself. Okay, this planet is truly in a league of its own. It doesn't orbit a normal, friendly star like our sun, no. It orbits the dead corpse of a star that already exploded in a supernova. And that stellar corpse is a pulsar. Think of it like a cosmic lighthouse from hell. It's a super dense, spinning neutron star that blasts out beams of lethal radiation. So instead of life-giving sunlight, this planet is just constantly, relentlessly getting blasted by high-energy particles that would sterilize any form of life in an instant. And then you've got this poor world. For Gliese 1132b, the enemy isn't the weather, it's gravity. It orbits so close to its star that the gravitational pull is constantly stretching and squeezing the planet, like you'd need a piece of dough. All that friction generates a ridiculous amount of internal heat, turning the entire surface into a global hellscape of nonstop volcanic eruptions. All right, after that tour through a cosmic haunted house, it's a totally fair question to ask, why? Why do we point our most powerful telescopes at these awful places where life is obviously impossible? Well, the answers are actually incredibly important for understanding our own place in the universe. Right, this is the key question. It's not about finding new real estate. It's about understanding the fundamental rules of the game, how planets are born, how they live, and, just as importantly, how they die. Take a world like Kelt 9b. By watching its atmosphere get blasted away by its star, we are witnessing planetary death in real time. This process, called atmospheric escape, isn't just some weird, exotic thing. It helps us build better models for how planets in our own solar system, like ancient Mars, might have lost their atmospheres and turned into the cold, dry deserts they are today. So at the end of the day, these hostile worlds are crucial benchmarks. They tell us where life absolutely can't exist, which, believe it or not, helps us narrow the search for where it can. They push our scientific theories to their absolute limits, forcing us to get smarter. And maybe most importantly, by showing us the countless ways a planet can go wrong, they are a profound reminder of just how rare, how special, and how precious a stable home like Earth really is. And that kind of leaves us with one final thought. In this big cosmic search for another Earth, another pale blue dot full of life, maybe the way forward isn't just about looking for paradise. Maybe it's by first understanding the infernos. By studying the absolute worst the universe can throw at us, maybe, just maybe, we're actually getting closer to finally recognizing, and one day, finding the very best.